Morning, everyone. So we have two questions as a warm-up. Um, we're going to go over these two. The first one I like to think of as a backwards problem because they give me the area and I have to find the value of x, which is the base. So think of this as if you were doing a problem like this on the homework. What I would expect to see, um, you don't have to write the formula out, but it's parallelogram, area is base times height. I would like to see what you identify as the base and what you identify as the height. And then we have all three things we're going to substitute in. The base we're going to call x, the height is 12, and then we can go ahead and divide. And if we divide by 12 to both sides, I get 23 feet is equal to the value of x, which is the base. So one of the things I want to just point out really quickly, if this was a homework problem, we are expecting that you're showing the work. The reason is I need to see what you call the base, what you call the height. I don't need to see all of the algebra steps, but I need to see the setup. And I would really like to see the formula because that's good practice that just helps you review all these formulas we're going to be learning. If you just gave me the answer, I understand that you could do this in your calculator pretty quickly, right? But we also want to see all of the work that you're doing. All right, especially for number two. Find the area. Now, this, you have a couple ways to think of it. I'm going to think of this as two shapes put together. You might not have done it exactly this way, but that's fine. We've got the area of the triangle, and I've got the area of the rectangle. And we know that the area addition postulate just says I can add the sum of two non-overlapping pieces to get a larger area. So I might call it my total area problem. So this T stands for total. So the area of the total is really the area of the triangle plus the area of the rectangle. And then all I need is a base 1/2 base times height for the triangle plus, I should have probably color coordinated this better, base times height for the rectangle. Right? Well, the rectangle is really quick. The base is 17. The height is considered 8. 17 times 8 is 136. And let's do this in blue. The triangle then, the triangle's base is the same length as the base of the rectangle. So that's 17. And the height is the distance from the base to the top, which is 5. And then we can multiply that out. And we get 42.5. And then the total area is the sum of those pieces added together. And then double check your units right now. Did you put feet squared? Because we are focusing on units as well. Okay. Well, today's work is focused again on area, right? And we want to find, we had the area of triangles, rectangles, parallelograms, and squares. Well, today we're moving on to the other types of shapes that we studied in Chapter 8. Little quote for today: the future lies before you like a field of fallen snow. Be careful how you tread, or it will show every step. All right, so we're going to start here, and we are doing section 11.2. We're going to get a handful of more formulas for area. As I recommended before, it is a good idea to do flashcards. And on one side, put the term, so area of a trapezoid, And on the other side of the flashcard or the note card, go ahead and put the formula for area. Remember the importance of this unit. If you do very well in this unit with area and you've really mastered all the area formulas, the next chapter, chapter 12, is going to rely heavily upon our knowledge of this unit. So my students that usually do well in chapter 11 do well in chapter 12. My students that don't do well in chapter 11 don't do well in chapter 12. So I just want you to realize there is a strong connection here. Okay, we have the area of a trapezoid. Now we're going to talk a couple of different things on how to view trapezoids. So I'll give you a second to write this down. And you may or may not know the formula for this. I'm going to show you one way that we can come up with the formula. So I'll give you a second to draw this. So remember when we studied trapezoids in Unit 8? One of the things we had to really identify is the definition of a trapezoid is it has one pair of parallel sides. So the two sides that are parallel, those are what we call the bases. And it doesn't matter which one I call base 1 or base 2, but that's what these little subscripts. So B1 is referring to base 1. It's the length of this base. And then B2 is referring to the length here. Now the height of the trapezoid is the distance between the bases. Now I can measure that distance here. I could measure it here, right? These are all the same. I'm going to erase this, so I'll only write this one. But I could also show that height outside of this, right? As long as I know the distance from base 1, base 2, it really doesn't matter where that height is actually drawn in. So don't write what I'm going to do next, but we're going to come up with a formula for how to come up with the area based off of the one thing that we know. Right? So don't draw this, but what if I double this trapezoid? Okay, so I flipped this upside down. You can see the base 2's match up. You can see the base 1's match up, and the height matches up. So what if I flip this over here and I just double this and I end up making a parallelogram? All right, so don't write this because we're going to just show you where this formula comes from. But what do I know? If I look at this big overall shape right now, that's technically the area is the base times the height. But what is the base? The base is this full length, which is base 1. Remember, this length was the same as up here because it was flipped. So base 1 plus base 2. All right, so instead of this B right here, we'll do that in red. Actually, let's do that in blue. B is the base of the bottom. Well, that's base 1 plus base 2. The height has not changed, right? The height is still the distance between the bases, and this height is the same. However, I don't want this whole shape. I actually just want half of it, right? I want to take away this piece right here. So if I know what the big area is, what if I cut this in half? And there is the formula for, see if I can get rid of that. I'll have to do this, hold on. There you go. So there's the formula for just one of those shapes, the original shape. And I'm going to write that much neater over here. But definitely write this part here. The area of a trapezoid is equal to 1/2 the base 1 plus the base 2 times the height. Okay? And that's where it came from. It came from the fact that if I just double it and make it in a parallelogram, you could generate this formula. And that's what we did. Now we don't have to do that every single time, but now that we know this formula, we can refer right to that. I want to draw another type of trapezoid here really quick. It's up to you if you want to include this. But for some reason, when students see this, they get really confused. They see a shape like this, and they don't connect with the fact that this is a trapezoid. It has that same quality. It has parallel sides, one pair of parallel sides. So I could call this base 1 and base 2. And then what makes this special is instead of the height being exactly the distance between the base 1 and base 2, it still is, but it actually happens to be a side length, but that's considered my height. So just keep this picture in mind when you see a trapezoid. Okay? And the reason why I think students get confused with this one is they think when we say base, they always think base means bottom. In this case, notice the height is the bottom. So base doesn't mean bottom. Base means, in this case, which ones are the parallel sides. That's base 1 and base 2. All right, and you don't have to write this. This is just officially the theorem. If you have this formula, we're not going to write this down. It just says the area of a trapezoid is half the product of the height and the sum of the bases. It's just a math way to describe what we have going on here. Please make a special note to have this formula memorized. For some reason, this is the one that students struggle with the most. You know, and I just was thinking, if you're not making flashcards, it might be a good idea to take a separate sheet of paper and just list area of a trapezoid. Here's the area formula, and maybe draw a picture, and then do it for, if you want to go back to the notes from last week, do it for the area of a square. Draw a picture, have the formula. Area of a rectangle, draw a picture, have the formula. Area of a triangle, area of a parallelogram. And that way you just have a list and everything's right there for you. Kind of like a little cheat sheet. Okay, let's go on to the next one. This one kind of gets kids stuck. So what I'd like you to do is you don't have to write these words here, but I'd like you to draw a picture of a rhombus with side lengths of 20 and a longer diagonal of 32. And see what you come up with. And then see from that information, is there anything else that you know? All right. Let's start off with a rhombus. If I take just the idea or just the definition of rhombus, we know a rhombus is a parallelogram with 4 congruent sides. So the side length is 20 for all 4 sides. And then it says the longer diagonal is 32. Now I'm not going to write 32 in yet, but we do know that because it's a rhombus, the other diagonal is perpendicular to the other diagonal. So we know that we have perpendicular diagonals, and the fact that this is a parallelogram, we know diagonals bisect. I'm going to cut this into equal pieces, and then let's put the actual lengths that we know. So if the longer diagonal is 32, and if I cut 32 in half, that's 16 and 16. All right. So we know, what else do we know? Well, wait a minute. This forms a right triangle. I can pick any one of these right triangles, but we actually have a special kind of right triangle. Okay, remember this one? You don't have to draw this, but if I had 3, 4, 5, we said that it's multiples. So I could times all these by something that would help get 16, 20, and something else. Well, let's see. 4 times 4 is 16. 5 times 4 is 20. So 3 times 4 would have to be 12. And that is giving me the length of this small piece here, which allows me to find the other diagonal. So Pythagorean theorem, or the fact that you remembered it as triple, allowed us to find the length of the other diagonals. Now, wouldn't it be nice, I'm going to erase that because we don't officially need to show that work if we know it's a triple. Wouldn't it be nice if I found a way to create a shape that was helpful so I could find the area of this, which is going to lead us into the area of a rhombus? Well, we could find the area of each piece, right? I could find the area of, technically, if I just find the area of one of these and I times it by 4, then that'll give me the area of the full shape. Or there could be a way to cut this out and form another shape. And I'm going to try this and see if it works. Actually, you know what? I might trace it. This might work the way I want it to, so, or it might not. What if I take this triangle right here, okay? And I take it and put it right there, okay? Now, that doesn't help me a ton, but look at what I did. Now, I created a parallelogram. So I took this triangle up top and I pushed it right down here in the bottom. So now I've got a parallelogram, and I know how long the parallelogram is. Okay, so you don't have to write this part, by the way. I'm just kind of showing you where this comes from. So I know that this length is the same as this length, which, notice, what is that? That is the small diagonal, which is 24. So the area here is 24 times, now the height of the highlighted yellow piece is 16. Well, what is that? That 16 came from 1/2 of 32. So instead of writing 16, what if I write, actually, you know what, I want to do this one, I want to put the order different. So what if I do 1/2 of 32, right? So here's the first diagonal, but I only want half of that. Now I could write 16, but you'll see why I write this in a second. And then the other length was the base, and that was 24. Well, let's think of this. Now we could multiply that out, right? 1/2 of 32 is 16. 16 times 24. We could find the area of that pretty quickly. But I don't really care about the area as much. That's 384 units squared. What I really care about, and we'll get this on the next slide, is what is this? This is 1/2. Well, where did the 32 come from? That was the diagonal 1, but we only wanted half of that because that's the height of the yellow highlighted parallelogram. So 1/2 diagonal 1 times what was 24? 24 was the small diagonal. So we actually generated, and this will be on the next slide, we generated the formula for a rhombus. Okay, so here's another view. If you didn't love that, watch what I'm going to do here. Okay, this is another view. Don't write anything until we get done with this. Okay, so here's my rhombus. Notice diagonal 1 shows on the outside, but this length here in green is the same as this length. So there's diagonal 1. And diagonal 2 is the length from here to here, which they show down here. Well, what we could do is, what if I double this? What if I take this triangle here and I just double it? Okay, and then I do the same thing here and I double it. And then I have the same thing here and I double it, and the same thing here. Well, wait a minute, doesn't that create a rectangle? And what is the area of a rectangle? It's 1/2 base times height. Well, that base is the length of one of the diagonals, diagonal 2. The height is the length of the other diagonal. But since I doubled it, I only want half of that area. So, what is the area of a rhombus? Well, it's 1/2 the product of diagonal 1 times diagonal 2. And that's what I'd like you to write here. So the area of a rhombus is just multiplying the diagonals and cutting it in half. Why do we cut it in half? Because if we were to double it, it forms a rectangle. I'm going to just jump back. So now I just removed those outside pieces so you can see just a regular rhombus. All right, so go ahead and write this. Draw the picture. All right, so we have the area of a trapezoid, area of a rhombus. The next one is the area of a kite. Now, before you write this, let's develop this just so you guys can see where it comes from. Because a lot of times, if you can just frame this in your mind, it helps you with memorizing the formula. And you're not really memorizing it, you're thinking of it conceptually. So let's look at this one really quick. What do we have? We have a kite. Now, why is it a kite? Because it has two pairs of consecutive congruent sides. And notice, opposite sides are not congruent. I will mention this. One of the properties of a kite is its diagonals are perpendicular. So you know that all of these are 90-degree angles. We don't have to put right angles for all of them. We're just going to put it for one. But we also know that the angle here, or I should say the diagonal here, is bisected. This is the only one that's bisected. You can kind of easily see that this length is not bisected. And it's usually, if you remember, this angle here is congruent to this angle here. So if you connect those congruent angles, that's the side length that is always bisected. Just an FYI. So what do we know? Well, watch this. What if I double this right triangle here, and I double the bottom one, and then I double these two? What did I create? The outside shape is a rectangle. So what if I develop that again? Now, I know, don't write this part because I'm going to erase part of it, but if I just treated this as a rectangle, well, that's base times height, right? But what is the base? In this case, the base is diagonal 2, and the height is diagonal 1. So I'm going to write diagonal 1 first. Doesn't really matter. You can multiply in any order. That's the commutative property. But I don't want all of the green ones. I just want the inside part. So what if I cut that in half? And that is the same formula as you saw for a rhombus. So I would go ahead and write this one. And actually, let me do this. I'm going to jump back so those green boxes aren't there. But that's how we found this formula, was we just based it off of a rectangle, and then we realized that the kite fills up half of the rectangle. So area of the kite, 1/2 diagonal 1 times diagonal 2. And you can probably guess, because there are right triangles here, that you're going to have to use Pythagorean theorem, or you're going to have to use the properties of the kites that we've learned in the past to help find the diagonal 1 and diagonal 2. Right? Very rarely do we just give you diagonal 1 and 2 and have you multiply it together and cut it in half. If you want to write the description of it, which I don't think you need to, the area of a kite is half the product of its diagonals. All right, so we have three formulas today. Area of a parallelogram, or excuse me, area of a trapezoid, area of a rhombus, area of the kite. If you can remember, the rhombus and kite, they have the same formulas, And then the special one or the tricky one is the area of a trapezoid. What I'd like to do now is do 3 problems. And I'm going to give you guys a couple minutes to work through these. I'd like you to show your work as if you were doing this on the homework. So draw the picture, label what you know, and then find the area. Okay? Some of them require a little more work. Some are very quick. But we're going to give you about, I don't know, let's say 5 to 7 minutes on this. Go ahead and draw the picture for each one and find the area, and we'll go over it when we're done. So let's go over these 3 problems. Hopefully you had a chance to try them all. One of the things you should do first is identify what type of shape you're dealing with. That should be the first thing you always do. And then I'm a strong believer of writing the formula down. Now you might have thought, don't we need more information for this? And the answer is yes, we probably should have had the parallel line symbols here. But what does that tell us? It tells us we have a trapezoid. And the next thing I would do is write the formula out. What is the formula for a trapezoid? It's 1/2 base 1 plus base 2 times the height. And then you identify, what do you need? Well, the base 1 and base 2 are the parallel sides. It doesn't matter which one I call base 1 or base 2. So I'm going to call those base 1, base 2, and then the height is always the distance between the bases. Now, sometimes they don't give you the height, or you might have to find it. So just really be careful and don't just assume because there's a number there that you have to use it or that's the number you need to use. Right? So sometimes we do have to find that. All right, base 1 we said was 6.5. Base 2 we said was 3. And then the height is 4. Now, sometimes students just get in trouble with this because they try to just plug everything into their calculator, and they're not great with parentheses. So my advice is let's do the addition inside the parentheses first, and then multiply. So the way I think of it is if I take half of 4, I get 2, and if I double 9.5, I get 19. And then I purposely didn't put units on this one to see if you wrote the words units squared. So even if we don't give you units, you should put units squared. All right, the next one is the one that requires the most amount of work. And you know, this I probably should have given you more information. That's my fault. This is a rhombus. You would have had to assume that had I not had these items in. So that's my fault. That is a rhombus. So once I identify it's a rhombus, I'm going to do 1/2 diagonal 1 times diagonal 2. Now notice, they give us 2 numbers. That doesn't guarantee that it's diagonal 1 and diagonal 2. So we have to be very conscious of what we're talking about here. So they tell me that AC is 18. Well, that is a diagonal. Let's call that diagonal 1. So I know I'm going to go 1/2 diagonal 1, and then I have to find diagonal 2, and that's where the work comes in. So what do we know? I know that CD is 15. CD is 15 inches, which means all of these are 15 inches. And then AC is 18. But as we saw, we know the diagonals of a rhombus are bisected. So I know that if AC is 18, then this length is 9, and this length is 9, and that still gives me 18. And then I have to work on finding the missing piece here. Now you might notice 3, 4, 5. 3 times 3, 4 times 3, 5 times 3. So 4 times 3 would be 12. So that's the fast way to know that each one of these small little pieces, or this diagonal cut in half, is 12. Well, then if I double it, that gives me diagonal 2 is 24. Now, we haven't done a lot with Pythagorean triples. So did I expect you to know that? No. Let me show you where that 12 came from if you didn't see it. And I think I got room up here. So this is a little side note. What if I just draw half of this triangle? We knew that this side was 9, this was 15, and then I need to define this length right here. Right? So got a right triangle. If you don't recognize the triple, that's fine. You can do Pythagorean theorem. And just do all this work and find the length of x. All right, so that's where this 12 came from. And then just remember that 12 has to be doubled to get the full length. And then the quick thing is just multiplying. Half of 18 is 9, and 9 times 24 gives me the area of 216. And then I decided to call these inches, so inches squared. So notice how Pythagorean theorem comes up. I guess if they really wanted to, they could have given you an angle measure here, and you could have done SOHCAHTOA because it's a right triangle. So just don't forget SOHCAHTOA, 30, 60, 90, 45, 45, 90, or Pythagorean theorem. Those are all items we could use to find side lengths if we have a right triangle. It just depends on what's given. All right, last one. What do we have here? We have a kite. So the very first thing I'm going to do is write the formula for a kite. It's 1/2 diagonal 1 times diagonal 2. And then I'm going to take my picture and identify what is diagonal 1 and diagonal 2. It doesn't matter which one I call diagonal 1, but the distance from here to here is the same as what they indicate on the bottom. So let's call the 19 diagonal 1. And then from top to bottom, that length is 10, so I can call that diagonal 2. And then I like to say, okay, well, let's see, half of 10 is 5, and 5 times 19 is 95. And then I called these feet. Okay, now just really quick, take a look at how I had shown my work. If your homework just has answers, you had just these answers, you didn't show any of this work, then you're not meeting the requirement of the homework. We need to see the formula. We need to see you substitute in, and then I can see the answer. Right? So notice, if I'm checking this work right here, I know the formula, I know what the students identified as diagonal 1 and diagonal 2, and then I got the answer. So I want you to practice that for homework as well as quizzes and tests. All right, so we've got some time. And what I'm going to do is I'm going to create a breakout room, and I'm going to assign a handful of people in breakout rooms. I need to have a couple conversations with some people that are missing things. So as you're waiting for me to go into a breakout room, I'm going to assign those. So once I assign them, and if you're asked, I'll have you go into the breakout room. If you are not asked, then you're just going to be working on 11.2 homework, which is due at the end of today. So I'll throw a handful of people in the breakout room. Please join, and I will be with you kind of in the order that it takes me to answer these questions.